Hey guys, this is video 12.1. This is the start for our acid and base unit. This video we're going to just talk about acid basics, so let's dive right in. One thing you guys want to make sure you do, you can see there's a lot of vocab, so you need to get that done ASAP. Your vocab quiz is going to be within that first quiz, the conjugate pairs one, so make sure you get that done as soon as possible. And it's going to be very crucial that, again, you know the terms throughout this whole unit. So we're going to talk today in this video, excuse me, sorry, about acid basics, like the properties and kind of some things to look out for and some definitions. So kind of the first part of this unit is very conceptual. You've got to know the terminology. Making flashcards is going to be a good thing to kind of keep track of acids versus bases. The good thing about acids, Table K in your reference packet. Get your reference tables out right now and flip to it. You don't have to memorize the common acids. They are on Table K. Make sure you know where to look for those. So we're not even going to get into the rules really for naming acids and bases. Bases are pretty straightforward, but if we need to, when we get to the end of the year, we might do a quick recap of it, but for the most part, those common acids that are listed there on Table K are all you're going to need. So let's jump right in. General properties, 5 general properties. It's highly encouraged that you guys make flashcards for these 5 properties. Kind of put acids on one side and then these 5 properties on the back. So acids 1, they have a sour taste. Okay, they have a sour taste. Some examples of acids would be something like citric acid in lemons, or citric fruits, or not citric, citrus fruits. Sorry, malic acid in apples. You've got acetic acid in vinegar, and you've got lactic acid, right? That's in sour milk. So you've probably heard of some of those. Maybe malic is the one you haven't heard of, but yeah, they have that sour taste because of the acids that are in those foods. So number 2, they contain hydrogen. Some will react with metals to release hydrogen gas. So that's another unique property, is that hydrogen piece. Acids also, they turn the color of dyes known as indicators. They can change it. We'll talk more about those later on in the unit. So an example, one you guys have used already, is phenolphthalein. Okay. Acids react with bases to produce salt and water. Now here's that term. We saw it a lot in the last unit, and so many people ask me, Mr. Conine, what's a salt? All right. And I said, well, it's not when you beat somebody up. Okay, haha. Salt, guys, you've got to know this. It's something I'm going to be asking you the rest of the year. What is a salt? If you can't answer that right now, already you're a little bit behind. It's an ionic compound. Okay, salt just means any ionic compound. So it doesn't have to have chlorine in it. It doesn't have to have sodium in it. Sodium chloride is the biggest example of salt because we use it every day, but it's any ionic compound. And we need to take that a step further, because I saw a lot of people confused. They couldn't even tell me what an ionic compound was. An ionic compound is where you have a metal plus a nonmetal, or you have a polyatomic ion in it. So you should be looking, do I have a metal in my compound? Do I have any polyatomic ion? Then therefore you have an ionic compound. And the last one is, excuse me, acids are electrolytes. Okay? They will conduct electricity in solution, and we're going to ask why. Why are they electrolytes? Why do they conduct electricity? It's something we're going to talk more about the rest of the year. It's because they produce or make ions in solution. Okay, ions have a charge. So for example, if we look at something like Na plus or Cl, those charges right there allow for the electrons to flow. Okay, if you don't have ions in solution, you won't have an electrolyte because they can't conduct electricity without those charges. All right, so our first definition of an acid, there's 2 that we're going to be talking about. You need to make flashcards for these as well. So you know these 2. This is more the traditional definition. So an Arrhenius acid is a substance whose water or aqueous solution contains or yields these things called hydronium ions. Okay? Hydronium ions. Now, you will see it written as just H3O+, which is that hydronium. Sometimes they may leave it as just H+, and we'll talk more about that later on, guys. But really with Arrhenius, you're looking, and you will, in this class, for the most part, see H3O+. So if you see H3O+ that has been produced in the final part of your products of your reaction, then you know it's an Arrhenius acid. And it's the only positive ion in solution, okay? So here's our example, nitric acid. Here's the acid, nitric acid, mixing with water, because again, it's an aqueous solution, and we see, hey, hydronium over there on the right side. It's the only positive ion. So for an Arrhenius acid, that's what we're looking for, is that H3O+, okay? So general rule for acids, hydrogen is going to be the first ion, okay? General, meaning it's not always this way, but it's a general rule of thumb when in doubt. It's always the first ion that is seen in the formula. So it's always the positive ion. And that's where that H+ kind of comes into play. Sometimes you might just see it as an H+. But note, guys, not all substances that contain hydrogen are acids. It's got to dissociate to form H+ ions. So you have to look at the entire reaction. If it doesn't dissociate or break up into H+ ions, it's not an acid. Okay? So an example of that would be something like C6H12O6, right? A sugar. It's got hydrogen in it, but it's not an acid. Something like CH3OH, that's methanol. That's not an acid either. Okay? So stick, for our purposes, you want to stick to the common acids on table K. That's going to be pretty much what you need to be on the lookout for this class. All right, so different types of Arrhenius acids. Okay, the first one is called a monoprotic. Okay, if we just break that term down, guys, mono, you guys know by now, or I would imagine, or well, should, because we've done naming. Mono means one. Protic refers to protons, okay? Protic sounds like proton, so if we just look at that root word, it means, oh, one proton, okay? One proton. So these are acids that ionize in one step, acids that produce one H+ ion. Okay, so if we were to break this down and dissociate this, we've got H+ and Cl-. One step, it's dissociated completely, and it forms all the ions. Let's continue on. We can also talk about this thing called a diprotic acid, okay? Where you have two, right? Diprotic, so di means two, and protic is protons. So this is acids that ionize in two steps. They produce two H+ ions in solution. Notice I keep saying ions, right? So when they break down, they have to have ions. So they are electrolytes, kind of going along with that basic property that we've already talked about. So here's what the two-step process would look like. We would get an H+. Okay, we know that it's going to form one or two of these, so the one is going to be in the first step. So think about what's left, okay? So if I take one H away from H2SO4, I'm going to have HSO4, but what else did I take? I took a positive charge. That means this whole piece is going to be negative. Okay, so we remove a proton, but we also remove a charge. So we're going to subtract from our piece that's left over that we remove that proton from. The next step, I can still get rid of another hydrogen. So now I'm just going to be left with sulfate. Okay, there's that two-step process where we get, if we take a look, here's one hydrogen, here's the second one. Notice what's happening with our charges each time of the other piece. The other piece keeps subtracting a charge because we're taking out that positive. So the charges have to be able to balance out. If we look at, based on law of conservation of matter and mass, guys, there's this thing called law of conservation of charge that we'll talk more about when we do redox chem in a few units. But notice how a +1 and a -1, oh, that has the overall of 0 like it does over there. In this one, we have an overall charge of starting with -1. That means our final pieces need to have that as well. So a +1 and a -2 is going to give us a -1. Okay? And the last type of acid is going to be called a triprotic acid. Tri, you guys probably know by now. You can see the pattern. It's going to yield 3 ions in 3 steps. Okay, so we're going to have 3 H plus ions in the end. So you've got H plus, and then it would be H2PO4 with a 1 minus charge. Next one, get rid of another proton. So now we have HPO4 with 2 minus, and then we'd have another H plus, and we'd be left with phosphate. Okay. Another term you might just see, guys, is this term called binary acids. Okay. So a binary acid only has 2 elements, so it's hydrogen plus something else. Examples of this, if you look on table K, HCl, you've got HBr, which is not actually on table K, but that would be hydrobromic acid, HI, hydroiodic acid. Okay, we have these things called oxyacids. So that prefix oxy, guys, it means they're going to contain oxygen. Okay, so they're going to have oxygen in there. So HO and a third element. An example of that would be H2, oops, that's not a 2, SO4, sulfuric acid. All right, and the last thing I just want to mention, kind of some life applications of these acids. Sulfuric acid is the #1 industrial chemical. It's used in making a lot of different stuff, such as fertilizers, oil refining, wastewater processing as well. These are just a few examples. This says wastewater. Let me erase it and just try to write it a little bit better. I'm running out of space. It's also an effective dehydrator. It's found in acid rain. It's one of those bad products of that. Phosphoric acid is also found in fertilizers and detergents. So one thing that companies are trying to get rid of is those phosphates that are found in a lot of that, because they can be damaging. It's also in some foods and pharmaceuticals as well. Nitric acid, again, common theme for a lot of these fertilizers and explosives. There was in the news a few years ago, it's probably been 6 or 7 years now, but there was a plant, ooh, lights just went out. There was a plant in Texas that just blew up because of those fertilizers, all those nitrates in the air. Last one, guys, hydrochloric acid. It's found in your stomach. And the last one, acetic acid, is found in vinegar. So, big thing here, make sure you can identify the difference between mono, di, and triprotic. Make sure you know the general properties. Make sure you know the definition of this Arrhenius acid and this general rule as well. All right, I'll see you guys in the next video.